AB Calculus Note Card 75, Solving Separable Differential Equations. This is the 75th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system. This is really a follow-up lesson to Note Card 56, which is particular solutions. So it's going to be a lot of the same thing. If you go to Note Card 56, you'll see this. Okay, an equation involving a derivative is called a differential equation of the form dy dx equals f of y times f of g is called separable. You occasionally will see this instead of dy dx. Sometimes you'll see this written as y prime, and if you do that, I recommend changing that to dy dx. Step one is algebraically separating the variables, integrating both sides of the equation, and if there's an initial condition, which usually there is, then you substitute and solve for c, then use the c to solve for f of x. So let's go ahead and work on these. Problem one, find a solution y equals f of x to the differential equation. You have a differential equation and an initial condition, and this sometimes is called a boundary condition. So let's go about the process. What you have is an equation like this. Now, a lot of times in our AP test, you'll be given a problem like this where you get points for each separate step to this. So you have dy dx equals 3x squared over e to the power of 2y. And what you do to separate, you try to get all the dy's and dx's together. So in this case, if we cross multiply the e to the 2y, and on the other side we cross multiply the dx over this way, what we're left with is e to the power of 2y dy is equal to 3x squared dx. So if this is part of an AP free response problem, you already get 1 point for just doing this alone. Now the next thing you're going to do is you're going back to the thing, integrate both sides. And when you integrate both sides, you want to have a d something on either side. So if we go ahead and integrate both sides like this, make the integral symbol, what we have on the left side is we have e to the 2y. Well, to make sure we get this right, if we made a u substitution, say let u equal 2y, then you have du is equal to 2 dy. And so dy therefore would be equal to du over 2. So what that means is when we integrate the left side, we're going to end up with 1/2 e to the 2y. And on the right side, the integral of 3x squared dx, we take x squared, raise that to cube, and divide by 3, which will cancel out that 3. And just to demonstrate for following along purposes, if we have 3x cubed over 3, the 3 over 3 will cancel each other. And then we have to add our constant of integration c. And now we're going to isolate y, get it by itself, and to do that we're going to multiply by 2. And so multiplying both sides of the equation by 2, we get e to the 2y equals 2x cubed plus c. Now you might ask, if we multiply this equation both sides by 2, why didn't we end up with 2c? Well, the reason is that we're going to end up with a constant here, and it's an arbitrary constant, and so whether we call it 2c or whatever, it's just going to be simplest to just keep it in terms of c. So now what we're going to do to solve for y, we're going to get rid of this e by taking the natural logarithm of both sides. So we'll say natural logarithm of e to the 2y equals natural logarithm of 2x cubed plus c. And what happens here is your ln and your e will cancel each other. So we have, I'm just going to bring it up here. We have 2y is equal to natural logarithm of, and what you're going to do, most of the time you take a natural logarithm of something, really you take the absolute value of 2x cubed plus c. And now if we divide by 2, we're going to have y solved for. So y is equal to natural logarithm of the absolute value of 2x cubed plus c all over 2. And now what we can do is take our initial condition, right, f of 0 equals 1/2. So we can say 1/2 is equal to natural logarithm of absolute value of 2x cubed, but x we found out was what? X we found out was 0. So we're going to have 2 times 0 cubed plus c over 2. And multiplying by 2, we get 1 is equal to the absolute value of c. Or lnc, rather. 1 is equal to absolute value of c. What we're going to have is you're going to have the natural logarithm of what equals 1? Well, natural logarithm of e. So c is going to be equal to 1. Okay, so that's going to be our value of c. And the last thing we're going to do is take our equation, the first one we solved, is this one right here. Plug it back in for this one. And working to the right, we have y is equal to natural logarithm of absolute value of 2x cubed plus e, and it's going to be over 2. And that's going to be our particular solution. So we have solved the separable differential equation according to the steps. All right, let's go on to the next problem, 2. If dy dx is 2y squared, and if y equals -1 when x equals 1, and so this right here is our initial condition. And this one right here is our separable differential equation. So what we're going to do is we're going to do a switcheroo. We're going to take this dx and multiply it out here. And we're going to take this 2y squared and divide the other side. So working below, we have dy over 2y squared is equal to dx. So what we have is 1/2 y to the negative 2 power dy equals dx. So we've done our separation. Now we're going to do our integration. So we integrate both sides. We get on the left side 1/2. We're going to get y, and negative 2 plus 1 is negative 1. And we're going to divide by negative 1. It's equal to x plus our constant of integration c. So coming up here, to the upper right, we have negative 1/2 and y to the negative 1 is y down here, okay, equals x plus c, and we're going to get y by itself. Let's get rid of the negative sign. Well, to get rid of the negative sign, we're going to have 1 over 2y equals c minus x. And then if we multiply by 2, we're going to get 1 over y equals, now remember, we're going to have a c here anyway, regardless. So we're going to keep this c here the same, minus 2x. And now we're going to finally solve for y by taking the reciprocal of both sides. So we have y is equal to 1 over c minus 2x. And this is going to be our general solution. And I'm going to just go ahead and label that as general solution. Okay, next, we're going to substitute y equals negative 1 when x equals 1. So on the left side, we replace y with negative 1. On the right side, we have 1 over c when x is 1, so minus 2 times 1. Okay, so we need to solve for c. And now we can take the reciprocal of both of these again. So we have c minus 2, and the reciprocal of negative 1 on the left side is negative 1. And then if we add 2, c is going to be equal to 1. And so we take this 1 right here, replace that c, it'll be a particular solution. So we're going to have, I'm just going to work to the right here, we're going to have y equals 1 over 1 minus 2x. So this is called our particular solution. Particular solution. Okay, next, it says then when x equals 2, y equals question mark. So now we're going to plug in 2. So we'll say y sub 2 is going to be 1 over 1 minus 2 times 2. So we'll have y sub 2 equals 1 over 1 minus 4. So we'll have negative 1/3. So that will be our answer here, using our general solution, particular solution, solving for c, and all that. Next, find y equals f of x by solving the differential equation. dy dx equals y squared times 26 minus 2x. So again, we have dy dx is equal to y squared times quantity 6 minus 2x. And we're going to cross multiply the dx, and we're going to divide by y squared. So we have here is dy over y squared equals 6 minus 2x dx. Okay, we have separated. So we're going to have y to the negative 2 power dy on the left side equal 6 minus 2x dx. Next, we're going to integrate both sides. So we're going to get on the left side y to the negative 1 power over negative 1. And on the right side, we're going to have 6x minus 2x squared over 2 plus our constant integration c. So what we're going to have here is negative 1 over y is equal to 6x minus x squared, and then working up here we have, we'll just take reciprocal, we got negative y equals 1 over 6x minus x squared, and then we also have our c over here. Must not forget that. So all we're going to do is change the signs. To do that, we'll have y equals, I'm just going to put negative 1 up front here, and we're going to have 6x minus x squared plus c. And this is going to be our, this will be our general solution. So now we're going to go ahead and plug in initial condition f of 3 equals 1/4. So we have 1/4 equals negative 1 over 6 times 3 minus 3 squared plus c. So what is that going to be? We're going to have if we multiply by negative 1 down here, if we divide by negative 1, we're going to get negative 4 is equal to 18 minus 3 squared 9 plus c. So we have negative 4, and 18 minus 9 is 9 plus c. And if we subtract 9 from both sides, this equation, we're going to have c is equal to negative 13. And so what that's going to be is, we take this value right here, we're going to have y is equal to negative 1 over 6x minus x squared minus 13. So this is our particular solution. So quite a bit of little algebra steps, manipulation to solve these, but they really shouldn't be that difficult. I hope this has been helpful to you. Good luck, and thanks for viewing.